All right, now this is an unfortunate one. This is a side angle side. So this is going to be the law of cosines. And so what I'm going to have to do is figure out a third side here so that I can actually do that. Now, so move to the other angles. Unfortunately, it does say solve each triangle, so I have to get everything here. Now, my guess is that the C is probably 30, and that we'll have to figure out A and B using the law of sines. Okay, so we're going to go with this guy because this is kind of set up for that. So we've got A would be 14 squared plus 19 squared. I'm just going to set this up real quick and then make sure that I type it in my calculator carefully. Okay, my calculator is in degrees, so that's good. So make sure that I take the square root of this guy eventually, so why not just do it now? Plus 19 squared minus 2, 14, 19, cosine of 130, and enter. Looks like it's 30, so that's exactly what we thought. All right, so this has some variety here. You'll notice that all four of these are different, so I'm going to shoot for B. I'm going to go for B to solve, but it looks like I could have gone A. So basically, if I just do the law of sine real quick, and I kind of wanted to show you this too. The sine of B over 19 equals the sine of C over 30. Now, I just wanted to show you that you can actually rotate these. You can put the sign at the top. In fact, some resources just do that. They'll put the law of sines as the sign in the numerator, but it's nothing, no big deal. So I'm going to multiply those two times the sine of 130, and then I'm going to divide by 30. I get 0.485. Now that is a sine, so I do the inverse sine. Okay, and I get 29 degrees, so that was B, and the only one to have 29 degrees is this guy. So I can get away with not having to solve for A, which, you know, I mean, if it's 29 degrees, take the 130 and add them, subtract the 180. Anyways, this one you have to use the law of sines. C is going to be 6 squared equals 6 squared. Oh, wait, no, I want A. So I need A. So that means I need 9 squared to be here because that would be lowercase a, and over here would be the cosine of A. Okay, so these have to match up. Make sure you do that. It seemed like you guys had no problem remembering that. And then these guys will just be the other guys. Okay, all right. So first of all, let's go ahead and take the 81. All right, we're going to subtract 36, and then we're going to subtract 14 squared. All right, so that gives me negative 151. Now I'm going to divide by parentheses negative 2 times 6 times 14. Okay, so that is my cosine value. So I need to do inverse cosine. And looks like I get 26 degrees. All right, find the area. All right, find the area. Okay, now this is a nice little formula. However, I will have to convert this to radians in order to use this beautiful formula. 1/2 AB times the sine of C. Okay. So what is that? Well, we're going to call that C, and we'll call that A, and we'll call that B. And so the area is just going to be 1/2 times lowercase a times lowercase b times the sine of 79. Okay, so that's nice. All right, so 0.5 times 7. Sorry, didn't do that to radians yet. So let's do 79 times pi. Try that again. 79 times pi divide by 180. Okay, that's how many radians there are. Now, I don't have a pi symbol, but that's okay. It's in there. I did multiply by it. So 79, it's going to be 79 pi over 180. That's what it would be. 79, I believe, is a prime number. 3, yes, it's a prime number. So that is it in decimal form, but that is 79 pi over 180. So what I need to do is just make this 1/2. Okay, and then it's going to be the sine of 1.379, but that is in radians. Okay, so let's convert this back to mode, and I'm going to put it back into radians. Second quit. Okay, 0.5 times 7 times 14 times the sine of this guy. All right, and we get 48. Round that up to 1. All right. Okay, now these are all three sides, and so to find the area, you actually need Heron's formula. So Heron's formula requires a C, and what you do is you essentially find, you need your S value, and that is called the semi-perimeter. So you take half of all of the sides added together, and then if you do that, you're going to get a really nice formula as a result. So, well, 0.5 times 12 plus, you could probably do this in your head. I don't know what I'm doing here. It's 13. Okay, so the semi-perimeter is 13. So now the area equals the square root of 13 times 13 minus 12, 13 minus 5, and 13 minus 9. Okay, that semi-perimeter should always be bigger than what those sides are, or else it's not the semi-perimeter. So this will be 13 times 1 times 8 times 4. So 13 times 8 times 4 is that. We're going to take the square root of that guy, and we get 20.39. So if we round that up to the tenths, we're going to get 20.4. All right. So we'll finish this off right here. Where we at? 7 minutes. Good. All right. So this is the unit circle. Okay. We're looking at the x coordinate. Here we're looking at the y coordinate on the unit circle. But this guy 390, he's above 360, but that's okay. So negative 315, where is that? 360 plus negative 315 means that I'm 45 degrees off of, I'm in the fourth quadrant, so I am 45 degrees. I'm negative 45 degrees. No, I'm sorry. Whoa, time out. Going the other direction. I'm positive 45 degrees. Okay. So if we go to, that is pi over 4. Okay, so this and this are the same thing. They're just going in different directions. They're called terminal. And at pi over 4, this is exactly what you got for cosine. You also have that for sine, too, at pi over 4. Now, the sine of 390 would be going in the positive direction all the way around once. Okay, and then an extra 30. So that is actually pi over 6. And the sine there is actually pi positive 1 over 2. Okay. All right.